Right, well, hello. Welcome to Retropower again. This is something we've been meaning to do for a while, but we've made the decision to do a full tour of and walk around of Retropower and say hello to all our facilities and our nice new workshop. We've been on this site now for 11 years, and we've grown the business a long way in that time. And as anybody who watches the Uncut series will be aware, we've undergone a lot of changes this year. We've done a lot of building work, and we've made a lot of moves around in the building. And we decided it would be a good time to give everybody a little tour of the facilities so they can actually see what goes on where and how everything ties together and how we build a car, basically, from start to finish. So I guess we'd start at the first place. If a customer literally walks through the door now, I guess one of the places we've usually had a few email conversations and probably a few WhatsApp conversations and probably quite a few phone calls by the point that somebody actually comes here. But when somebody arrives and we're going to have a little quiet discussion about a project and just sit down and get the bare bones of the ideas put together, probably the first place you'd see will be our new little meeting room. So wander this way and we'll have a look in there. So here we are in our little meeting room that we put together. We hadn't had one of these for a long time. We decided we needed somewhere quiet to sit down and discuss things that wasn't the middle of the office, because we keep getting tied up in office business rather than chatting about actual projects. So we'll have a sit down and we can talk about project ideas. Obviously from the early phone conversations that might go on around a project, followed by a lot of WhatsApp conversations normally and a lot of emails and floating of ideas, we then get round to a stage of perhaps coming up with some renderings to describe the basic principles of a project. There's a few examples put on the table there. These are just the very basic outlines of the ideas of some of the projects we're actually working on, and also ones that we have in the pipeline. So there's a few ideas, and we'd probably have a sit down, discuss the basics of a project. We've got a bit of a backdrop out into the workshop now, which is a bit more pleasant than just all being hemmed in a box. So we can see some of the other projects that are being built and see the work going on in the background, which is always a nice little, brings a nice little buzz to the environment. And then we've got a few little photos that sort of sat nicely, photos that were close to our hearts from many years of car building. Really covering, going over there. You know, the Ascona 400 at the end was completed in 2011, and in fact actually recently used by its owner as his wedding car. And then travelling around, we've got some of our favourite projects from over the years, and some of our clients that have become close friends actually, and some fairly well-known clients, and some very nervous members of the Retropower team looking on. So yeah, so it's just a nice little environment where we can have a chat about projects and come up with drum up all the ideas and make the decisions right at the beginning of our process. So from there we will move on. So moving on from the project outline ideas, we'll pick up we'll do a little aside at this point and nip upstairs, because there are a lot of parallel processes occur, obviously, during the design and development of a car. And one of the principles we have at Retropower is trying to keep most of the operations in-house. And we talk about design of components quite a lot, but what we probably don't show very often is them actually being designed. Now, I can't actually show them being designed today. Our staff aren't here today, but what we will do is just pop upstairs and I'll just show you our little design area, because our team's growing quite significantly at the moment, and we realised a couple of years ago, I guess, probably a little bit longer ago than that actually we need at least one and probably more full-time CAD designers. So now we've got, my computer shut down, oh well. We've now got a bit of space up here, which we've now allocated to workshop management, but also CAD design. There's basically two people almost constantly up here now doing CAD work. One absolutely full-time, George, who's our newest recruit, sits there, and he's doing probably 75–80% of our CAD work now, and keeping a 3D printer extremely busy doing prototype parts. So he's drawing up most of our CAD work. with a bit of work from others as well. And this area's got to evolve a little bit more yet to become a bit more permanent. But certainly we have 1.5 people probably constantly up here now doing CAD work, and also some of the Photoshop work, some of the initial design work, like the renderings you saw downstairs were not done up here, but there is other Photoshop work carried out just in the early stages of car design, just to get the ideas that we need to be able to go on and crack on with the metalwork further along the process. So that's our design space. It got to evolve a bit, but that's the design space. Outside the windows, you'll notice it looking a little bit cluttered there, because that's actually now our mezzanine floor stores area just outside this door. Again, things have evolved a little bit along the way, but that's now our storage area for parts for all the projects that are in process. We'll tie into that shortly, because when we see the next stages of the actual physical work going on, that'll tie nicely in there. So at this point, what we'll try and do is, following on from the design work and the background work, we'll try and pick up the process as if we're following an actual car through the process route within Retropower. I think that'll be the easiest way to explain the facility and how it all should work if everything goes to plan. So, car comes in through this door behind us. That's the first stage. We come into the Fabrication Workshop, which is a nice new airy space now we've reorganised it. And I guess an ideal place to start will be here, where we have the lift that we have in the Fabrication Workshop. We have 4 bays in here, and the first one has the lift in it, and it's where we do our initial strip down work on any car coming in. We don't like to do the strip down work, if at all possible. We don't like to do it in the assembly workshop, because it's usually dirty work and we don't like dirty things getting in there. So we do the initial strip down work in here, and as luck would have it, we have this BMW M3 sat on the lift being stripped down, which literally just got started on Friday, yesterday. So that's now in the process of being stripped down. And as you can see, it's basically a car being taken apart on a lift. We take all the parts off, they get put into, the bulk of the parts, not including the engine and gearbox, but all the smaller parts, get boxed up into these pallet boxes. These are then taken through to next door, and that's where we tie into the stores that we saw earlier, in that these are taken round, loaded onto that mezzanine floor, and then up on there, all the parts will be gone through, and the process routings for all of those parts that are in those boxes will be decided at that point. But that's the first stage will be, car comes in here, onto that lift, stripped down so that it's back to a completely bare metal body shell with not one single bolt-on part left on it, so that we can then see the metal body shell that we're dealing with and what we have to work with. And at that point, we obviously then need to bear in mind, going forward, all the design work that's gone on in the background. We have to keep that in our minds, that's key to the whole process. But yet, once we've got that car stripped down to a bare body shell on there, we'll drop it onto one of our trolleys. We've got many of those floating around. They're not in here at the moment because they clutter the place up, but we've got lots of trolleys. We'll load that body shell down onto a trolley, and then we'll strip the under seal and the seam sealer and all the soft compounds and everything off it. That's a pretty painstaking, slow job done with scrapers and very manually intensive. We'll strip all that coating off and all the soft things that don't like being media blasted. We'll strip all those off, and then we go through into our media blast room, which we have the lights on in here. I'll wander into there. And this is where the real first stage of cleaning up a car happens at Retropower. It's not the most photogenic space, but it's not the most photogenic operation. It's not a particularly pleasant operation for anybody that's ever done it. This is where the body shells are blasted, and some parts as well, but mainly we mainly blast the body shells in here. They're blasted using, it's a common question we get asked, they're blasted using this crushed glass. It's recycled bottle glass. And it's the abrasive that we found to be best for cleaning up body shells. It's very light, it doesn't carry too much weight, it's quite light, so it doesn't distort panels. People talk about distorting panels when you blast body shells. It is possible to distort panels, But it doesn't generally happen if you're careful and you do the process in a controlled fashion, and it depends a little bit on the panel. You can't blast very big, very flat, very thin panels, but most panels with a normal amount of curvature can be blasted fine. So in here, we blast the body shell. The grit goes through a recycler, which we kind of built ourselves, and there's a filtration system which we built ourselves, and lots of other things, and lots of other complication that isn't particularly relevant to building a car. But this is the space where the car becomes blasted back to bare metal over the entire car. And then we'll generally put a very, very light coating of an etch primer, just very light. What you have to remember is, we'll touch on this a bit further along the line, but in our process route, the car will always be blasted again after metalwork. It's blasted before any metalwork, but it's also blasted again after metalwork. So if any slight bits of surface corrosion happen during the metalwork process, that's not really a problem. It'll be blasted again anyway. So every car visits this room twice. So moving on from there, we go into the Fabrication Workshop, where there's a lot more detail to go into. It's, again, keeping the in-house ethos. Not that many restoration companies have their own blast facility. We consider it pretty essential because we also undertake a zinc metal spray process on every body shell that we prepare, and that necessitates having a blasting facility to go hand in hand with that, because the zinc metal spray has to be applied immediately following a blasting process. So we need this facility to be able to do that process as well, which is another reason for keeping this process in-house. But moving on, we'll go into the metalwork area and show you a few bits of what we have floating around there. So we've covered the media blasting, so we've blasted our body shell, and here conveniently is an example of a body shell that has been media blasted and then covered with a very, very light coat of etch primer just to prevent any surface rust. And we've now fastened that down to one of our two select jig benches, which we use. Any chassis work that we do is all done on a select jig, so that nothing can move. The body shell all stays in the correct orientation. No suspension pickups can move, and everything stays in the right shape. So that's now fastened down to the select jig bench, so we can start on the metalwork. And then moving round, again picking up design aspects, we have a very crude Photoshop, but very effective Photoshop of a Mark II Jaguar converted to a coupe. It's converted to a two-door coupe, which is what is happening with this particular car. And this is quite a good example of the next stage in the process, in that, as I've just said, it's blasted, it's now fitted to the select jig bench, and then we're just under a week. I think we're about 4 days into metalwork on this body shell now. So Stu's been working on this one. He's our senior metal worker. He's set to on this, and we are lowering the roof, hence all the work here. And we're going to be making quarter panels, we're going to be making doors, we're moving the B pillars, we're altering the roof, we're remaking the back of the roof, and we're remaking the rear window aperture. So there's a reasonable amount, not one of our most intensive projects, but a reasonably intensive metalwork project. And that ties us into all our fabrication equipment quite nicely, because, as I say, making a full quarter panel from scratch, that'll be made from flat sheet. We'll be making a door, it's a two-door. We'll be using the components of the door, the original Jaguar doors, but we've got to make the doors longer. So we'll be making a new inner frame, a new skin, and a new frame on top, all of which we'll make in-house. Same with the quarter panels, that'll all be made in-house. The roof extension on the back and the modifications to that, we'll do all that here. And the window apertures, we'll do all that here. All of this work is done in-house. So we'll move on, and I shall show you where that takes place. So we come into the fabrication machinery area now of the fabrication workshop, and we start with flat sheet metal at this end. We start making from here, and it depends what we're trying to make as to what we're going to use, but I'm going to try and talk you through a bit of a few examples of what we might be doing. Pretty much the first operation, any sheet metal that comes in, you've got to chop it to size. So that gets cut to size on this rather ancient guillotine we have here. So that's pretty much the first stage of most panels we make. They're cut to size on our guillotine. There's a number of ways of cutting things, but that's pretty fundamental to the process. Then we've got various bits of machinery. We've got this little formit machine for folding little things, and it's got some little rolls on it for rolling small shapes. And we've got a folder here with a radius bar on that we use for folding certain things. We don't use that one that often. It's just for folding certain shapes. This machine is our main folder, our main thing for putting creases into sheet metal. For example, on the Jaguar, and all the returns which are straight on the door panels, for example, the bottom edge of the door, which will be a straight line, well, it'll be a straight line when it's initially shaped. There will be a slight curve in it, but it'll be a straight line initially. We'll put that fold in on the bottom of that door skin for the Jaguar. We'll put that fold in on this machine. So once we've cut the sheet metal to shape, this would be where we would put the fold in on the bottom of that door skin. Then moving on, a slightly more interesting machine is it's a Henry Pell's nibbler. A lot of people in the sheet metal industry would refer to it as a Pullmax machine. It isn't made by Pullmax, so it isn't a Pullmax. It's a Henry Pell's, dates from the 1940s. It's just post Second World War, I think this one, or pretty much bang on the end of Second World War. And we use this to put profiled shape in straight lines or curves into various sheets. Put reinforcing beads into panels. That's actually a beading die, a homemade beading die that's in there at the moment. It's basically a reciprocating machine that hammers a profiled shape into a panel. So I can show you a little demonstration with there's a set of dies for it. That would be a die that we would use to put flutes into a floor pan, to put profiled ribs into a floor pan. We just make these from plate and round bar stock as we need them for when we need to put shapes into pieces of metal. There's an example. I can show you a slightly more complicated example here if I fish it out. Here's a more complicated tool which we use to put a much more complex shape into a panel. I think that was a sill panel that was used to put some steps into a sill panel. As you can see, we can hammer a reasonably complex shape into a panel with this. And as the example on the Jaguar, we will use this. We'll definitely use this to put a profile onto the edge of a wheel arch panel for the quarter panel, and we will likely use it for putting the profile into, when we make this rear window surround, to put this shape here onto the edge of the rear window surround. We will make a die up to put this shape in when we remake, because this piece has got to be remade. When we make that, we'll use dies in that machine to put that shape onto the edge of those panels. So that's another process here for putting reasonably complex shape into sheet metal panels. So that's that machine. Moving along, we go past linishes and grinders and things that every workshop has really. You kind of need all those. My favourite old bit of kit, you become very attached to certain tools. That's a 1930 something, I don't know the exact year. It's around 1935 speed axe bandsaw that I'm really quite attached to. So we really like that. Then we've got various bits of home-brewed or at least semi-home-brewed equipment. We've got this, which is my kind of semi-homemade shrinking machine. It was a Bailey foot-operated kick shrinker that I've modified to take a very large air cylinder, and we use that for putting deep shrink into panels where we're making a panel with substantial curvature, like a front wing for a Morris Minor, for an example, because we used it on that quite heavily recently, where we need to put a lot of shrink to curve the edge of a panel around onto itself. We use an English wheel to put the main curvature in, but where the sides need to curl in initially, the initial shaping of the edges, we would use this. This can work sort of 6 inches or so into a panel, and its shrinking power is absolutely immense. We can shrink 16 gauge steel 6 inches into a panel with this. It can exert an enormous amount of tonnage on these jaws, and it's just so fast compared. We can shrink the old-fashioned way. I'll show you that in a minute. We can shrink using a stump and a blocking hammer, which we still do. That puts less marking in than this, but this is so much faster. We can pull shrink in so much quicker with this. It's such a useful piece of kit. So we were really happy to have brewed this one up, because it's a very useful piece of equipment. Walking on round, we have a set of bending rolls, again pretty fundamental. When we first shape up the door skins on the Jaguar, What we'll do is we'll put the initial curvature in one direction in on these bending rolls, and then we'll put it in the wheel and put the compound curvature in. Makes life a little bit easier, stops the panel flopping over in the rolls, and just makes life easier when we actually start using the English wheel, which, after we've walked past the fly press, which we use for all manner of things, embossing, we do some nice little embossing jobs. I'll point one out in a minute in that. We make dies for that, and pushing bearings in and all sorts of things. You couldn't be without one of those. We walk past our fabrication bench, which is a table of unknown origin, other than that it was heated or cooled at some point in the past, and I won't go into all that. Look at our tool time videos for the detail on all that, but I'm quite attached to that table as well. And our TIG welding, our main TIG welding plant there, which we use for with a huge amount of, that's running every day, stitching panels together, doing all manner of operations. That we've got various TIG welders. Shooting off on a side, at this point, we've got 3 MIG welding plants that we use that float around the workshop. There's one over there, one over there behind camera, and then we've got currently 2 TIG welding plants, plus another little inverter that we can use now and again, but we will be having a 3rd TIG welding plant imminently. So we've got quite a variety of welding kit. That Hitachi inverter is a brilliant bit of kit. That's beautiful. We can weld anything with that. That's a really nice machine. That, so we can weld anything we need to do here. Aluminium up to huge thicknesses. It's a 300 amp machine. That'll weld anything we need to weld. It'll weld down to 5 amps really accurately, so we can weld super thin materials with it as well. It's just a lovely bit of kit. Moving on from all that, getting very carried away now, we'll move on to the English wheel, which ironically is one of the bits of kit that's American made. It's our American built English wheel, because we really struggled to get a good second-hand cast iron wheel, and it actually ended up being easier to buy a nice new one. This is used on any project, obviously, where there is compound curvature. This probably isn't the time to go into a lecture about how an English wheel works, other than suffice to say there's a lot of rubbish on YouTube to be avoided, and there's some very good videos on YouTube as well. But yeah, an English wheel basically stretches metal. That's all it does, and we use that to form compound curvatures on various panels. And it will be used, going back to our reference Jaguar, it will be used to make both the rear quarter panels for that, because we're making full quarter panels, and it will be used to make both the door skins on that, because we need to put compound curvature into all of those. And it'll probably be used on the rear section of the roof a little bit as well, because there's a slight bit of compound curvature on that as well. So whenever we need to do compound curvature work, English wheel's the go-to tool. There's all the little rollers down there, varying radiuses to get into various curvature panels. And that's a lovely bit of kit. We can also put single curvature in when we need to, if there's some other reason we can't do it. Just down here by this dustpan, we have a slightly dusty rubber wheel, which we can put in instead of this top wheel. And we can use to put a single curvature bend into something that's awkward to get into the forming rolls if there's some other complication. I can't think of an example now, I'm on the spot, but transmission tunnels, that's where we often use that. When we're shaping a cone in fairly heavy steel for a transmission tunnel, it's often quite awkward to get into the bending rolls, so we quite often use the rubber rolls in English wheel to put the shape into a transmission tunnel. It's just a bit easier to do than it is in the plate rolls. So that ends the tour round the fabrication machinery in here. There's other bits in the background actually that I've probably skipped past. If I wander back this way, we've got a couple of we've got a shrinker and a stretcher here that we use for small flanges round windows for the lighter duty work. We've got a shrinker and stretcher from Matt at Stakes's Metalwork machinery. We use those for the smaller lighter duty work, and we've got a set of hand operated swage rolls here, which we use for wire edging panels, sort of again on the quarter panels on the Jaguar. There's a couple of places where they'll be wire edged, so we would use these for putting the grooves in for wire edging and for closing wire edges over on panels, and also just for putting swage lines into panels where we don't want to do them in the Pell's nibbler. It's not used every day, but it's used pretty regularly. And then also handily in the background now is our second select jig bench, which is a bit more clear to see now. Now we're because it's not got a car on it at the moment, unusually. So that's the foundation of any chassis build, any body shell work that's done where cuts are being made. These are the foundations of that work. No car is worked on and with that level of surgery without first being bolted down using a whole raft of fixtures and fittings that are in a separate room back there, being attached to these first, and these are set perfectly level as well. The floors in here are not very level, but these jig beds are set perfectly level so that we can use levels as a reference when we're working on the cars, and we can laser level sections of the body shell to make sure they're all in alignment as we work on the car. So they're a real fundamental to the process of body shell work at Retropower. So just flitting back very quickly, back to the fly press, if I may, because I can demonstrate something quite neatly here. We have, although albeit covered in glue, we have a neat little tool on the fly press that we made that's quite relevant to the car that was in the background a moment ago. This is an example of, when I talked about an embossing tool earlier, we make various tools for this fly press, this old, very old school hand tool, to put embossings into steel panels. And I can show you a good example of one on this Morris Minor. All will be revealed in a minute. This will all make sense in a minute. There's the example of what that tool was used to do on the bulkhead on this car. It's been used to look nice and also reinforce the panel and take any drumming out of that panel. So it's there for a couple of reasons. And that embossing was put in using that fly press with that little die that I just showed you that we'd made on there. And the interesting bit is tying in from the very old-fashioned, very old crude hand tools like that to also keeping slightly more complex processes that are integral to a lot of things we do in-house, is that tool that you just saw there was actually made on another piece of machinery that we have that we can show you just through here. And we'll walk this way. So here we have our Cnc Plasma Cutter. We bought this, I actually lose track, 3 or 4 years ago, possibly 4 years ago now. And it's used intensively. It's probably used, I would say it's used every day, and quite often a number of times a day. And it's used for a mixture of work, but it was one of those decisions, do we buy one of these and bring this process in-house or not? Now I don't know how we manage without it. It's used for prototype parts, for test fitting parts. It's used for production parts, suspension brackets, transmission mounts, engine mounts, all the parts that we do on a typical custom vehicle build. Dashboard brackets, door parts, locking mechanism parts. Just a huge number of parts that actually get fixed to a finished car are made on this, but also huge amounts of the tooling. And that ties into what we were just looking at on the fly press. That little Morris sign, the little Morris emblem that we've embossed into the bulkhead, that emblem, the die to stamp that was actually cut on this machine from 3mm thick steel. We drew the emblem on CAD, and then we cut those parts out on here, clean them up, put them on the fly press, glue them on, and then emboss those parts. So that's where this machine makes an awful lot of tooling. And in fact, going back even more abstract, the shrinker that we were looking at, the big pneumatic powered shrinker, the actual arm on that and all the brackets that hold that pneumatic cylinder on that were also cut from 10mm thick steel on this plasma table. So it lends us so much flexibility that we can now rapidly, rather than drawing a part on CAD and sending it to our laser cutters, who are very good. There's a laser cutter down the road run by a really nice guy who cuts us stuff usually same day, but often certainly within a couple of days. And he's a very nice guy, very helpful, but it's never quite the same as being able to literally draw it and have it cut in 10 minutes. In 20 minutes, you've tried it on the car. In 25 minutes, you've edited the drawing slightly. And then within half an hour, you can have made the part twice and got it fitting perfectly. Whereas if you're relying on a subcontract job, it might take you a day to get the first part, then you need to make a tweak, then it takes you another day to get the second part. It's just so much faster. So yeah, that's an absolutely invaluable machine and another process as the Retropower way, everything in-house, wherever possible. And so that's a very useful piece of equipment. And then to my right, because it happens to be to hand, although it doesn't particularly tie in with the metalwork side of things, is our other little rapid prototyping machine, I suppose, which is our 3D printer, which lives out here, out of the way, where it's nice and on its own and quiet, and it can buzz away 24 hours a day, which it has been doing quite a lot recently, making prototype parts. In fact, there's actually a part in it which I can pull out, and I haven't actually planted this here. This was printing last night, which is quite a large piece. And it gives you an idea of the scale of the printer. That is a prototype part that George finished drawing yesterday and set printing as he went home, which is the rear half of a screen wash tank and engine breather tank for one of our other projects. That would be, the final part would be machined in aluminium billet, but this is printed in PLA, tough PLA, and then he will print the cover set, the other half of this tank, which bolts onto it. These are all O-ring grooves, it all bolts together. He'll print the other half of it, and then we can trial it all in the car, make sure everything fits. We can spot these holes here, we'll be bolting this to the car, so we can spot these locations onto the car and make sure all the brackets, and well, there's no brackets, but the spaces and the spotted locations and the threads that have to go into the car are all done using this plastic tank. In the meantime, once we've confirmed all that, the drawings will go off to our, this is one of the jobs we do send out, is the more complex CNC machining work is a job that is subcontracted out. Those drawings will be sent out to the subcontractor and they will machine the parts. But in the meantime, we've got the plastic parts so we can check fit, do any development work, and then we can also keep these so that if in the future we need, for some reason we need to refer to something, we've got the physical part to look at, to check if there's a problem in the future for some unknown reason. So yeah, that's the 3D printer, which is again in typical Retropower style, a home-brewed piece of equipment. It was a Chinese, it's a Creality CR10 S4 printer, bought because it's one of the machine, it has a huge print envelope. It's a 400mm by 400mm by 400mm print envelope, which is big. They do a 500, but the bed heat becomes a major issue on that. I won't go on a full tangent of talking about too much of that, but it's a 400 by 400 by 400 build volume. It's a printer with many weaknesses because it's quite cheap, but we've overcome those weaknesses by re-engineering almost all of it. So instead of having instead of the original drive system it had, this now has a completely different drive system. It's got a different extruder, a different hot end, a different motherboard, different wiring. It's got a double glazed thermal enclosure and a remote wire feed. There's a remote plastic feed. Everything's been changed on it. So now it's actually really reliable and we get on really well with it. The last 2 or 3 years, it's just been going flat out making parts for all of our builds, doing prototype parts and a few production parts. It's actually made a few parts that are actually permanent fixtures on cars. A lot of interior trim parts. It's really useful for making the more complex interior trim parts on the cars we're building, particularly where they're then covered in leather or flocked finish or some other finish is applied. We actually make the parts in a different plastic. PLA isn't heat resistant, but we print PETG with a carbon fibre particle reinforcement in it, which we can then use as actual production parts for interior plastics. So it does actually make some parts that actually end up on customers' cars as well. So it's a very useful piece of equipment. So I shall wander along this way. So following on from our various metalwork processes, which we've skimmed over, I know, I could be here forever talking about metalwork because it's kind of my passion and the thing that that I actually enjoy as a hobby as well as a job. But we would then we get to the sort of stage that this Land Cruiser's at. It's not quite at that stage, but we get to this sort of stage where what we perform towards the end of metalwork for every vehicle that we build is a full dry build, because what we need to do is make sure that we've made provision for everything on the vehicle before it's painted, because we don't really want to be drilling holes or making brackets and things on cars that are painted. Inevitably there is, I'll put the caveat here that inevitably we always have to drill a few holes in a painted car. I'm not going to make out that we never do any, because that would be lying. But what we try and do is minimise that and make provision for everything. So as a few examples plucked from the air, just to give you a feel for these things, wiring loom brackets. You know, when a wiring loom is fitted to a car, the wiring loom needs to be attached to the car. Because we've extensively re-engineered pretty much every car that we build, the wiring loom brackets are usually the original wiring loom clips and brackets are either not really very good or are irrelevant because they're in the wrong place. So as an example, we would be putting mountings in for the wiring loom, little threaded bosses or threaded pins or retaining clips or things into the metalwork for mounting a wiring loom. Same for the plumbing. Using this car as an example, this is being fitted with a new heating, ventilation, air conditioning system, which has all been mounted under the dash. We've already put all the bracketry in to mount all that, and it's a nice new modern electronically controlled system. So we've got wiring to provision for that. We've also got the plumbing to provision for. We've got the aircon pipe to provision. We've got the heater ducting because all that's been changed as well and upgraded. So all of these things have got to be fitted and brackets made to attach them. The dashboard, all the instrumentation's been changed. We've got a bracket for all the instrumentation. And the list goes on and on and on and on and on. So we've got to do all of that. And this is pretty much at that stage. We're actually doing seating on this at the minute and fuel tank provisions and fuel routing provisions. And we're actually literally at the moment working on the fuel filler pipe. But all of that comes into what we would call dry build. So this car's basically at the dry build stage. That takes quite a while. It's quite detailed. There's quite a few, a typical build, there may be quite a few weeks of that sort of work going on. Once all that's done, we'll then completely take the car apart again. We basically build the car twice. We completely take the car apart again, so it's back to its bare body shell, stroke body shell and chassis in this case, components. And then they go back to the blast room that we saw earlier, and they're all reblasted, and then all the ground facing parts, i.e. on this, the chassis and the underside of the body tub, and on a typical car, all the underside of the body shell will be blasted and zinc metal sprayed. And we want our cars to be a legacy. We want these to go on and on and on and to outlive us. And so that's what we do. We zinc metal spray the underside of the car. And then once that's done, following that reblast, we also blast all the new metal and all the old metal to key it all up and prepare it and remove any traces of corrosion. And then very quickly following that, we de-dust the car to get all the blasting dust out of it. And then we epoxy prime with a very high corrosion resistance epoxy primer on all the areas that have not been zinc metal sprayed. And conveniently, behind the camera, we'll move over here. This Morris Minor just happens to be at that stage, and everything's fallen into place quite well for this. But this is just a week ago, or just less than a week ago, has been reblasted, and then the upper half that you can see here, this is all corrosion-resistant, high zinc content epoxy primer, and then all the underside, which is also silver, so it's hard to see the difference, has this slightly coarser finish on it, which is the zinc metal sprayed finish. And as I say, that's used in marine applications, marine wind turbines, oil rigs, bridges, a huge number of applications where salt water, intermittent salt water immersion or salt spray is heavily impinging on it. It's a very, very durable coating. We've actually had samples of that tested by an independent test house. And basically we stopped the test. The long and short of it is we stopped the test. The test, we tested it to 3,000 hours salt spray. That was the zinc metal spray coating, followed by epoxy prime and then a U-Pole Raptor, which is a truck bed liner that we use on the underbody of all our car builds. That was then scribed through to the bare steel as per the standard test procedure, and then salt spray tested in an accelerated test cabinet. And they were tested to 3,000 hours salt spray endurance with zero red rust, zero red corrosion at 3,000 hours. That's unheard of. Basically, the automotive industry, the most stringent test on any component within the automotive industry that I know of is a 500-hour salt spray test. There's a little white corrosion from the zinc, but no red corrosion of the steel underneath it. So we will put our names to the underbody coating that we use. It will not rust. And it also allows there to be the damage from real world use what the big benefit is that when we jack a car up or otherwise damage the underbody, which is inevitably going to happen, you take your car to a quick fit to have some tyres fitted, they jack it up and chip the undercoating on it. It happens, it's not their fault, it's just that's what happens. When you jack your car up, you damage the underside, or you hit stones in the road or whatever. You do some little bit of damage underneath. If you don't have a sacrificial coating like the zinc, you chip the paint coating on the underbody, rust starts, it blisters, and you quickly start corrosion, and that's where you always see rust on cars, on the sills or areas they've been damaged. With this coating on, you can chip the overcoating as long as the zinc's there. Even if the zinc is damaged, it'll still sacrifice itself to protect the steel, and so the car just lasts for an awfully long time. And the epoxy primer again is another very good, very high anti-corrosion. It's actually a marine primer we use on the upper part, just as the initial coating. Obviously there's a lot more goes on. That then leads us neatly on to the body shop area. So here we are in our new, fairly tidy prep area. This is where we do all our body prep, following on from all the metalwork and then the zinc metal spraying and the epoxy priming that we've done on that you saw on the Morris Minor body shell. We then come into this area, which is our body prep area. And this is basically where all the soft dust work is done, where there's any fiberglass dust work, any filler dust work, all the body prep work that goes on onto the metalwork to then get the body shell to the stage where it's all ready for paint. So basically a lot of sanding. The crux of this area is an enormous amount of sanding, and one of the things that we'd always struggled with in the past is dust extraction. We'd had dust extraction on the tools, but actually the area generally becomes pretty dusty, and then that migrates into the rest of the workshop and makes the place look a mess and yada yada yada. So we've now made this, if our door was here, which our courier kindly lost, this would be a relatively sealed environment, and we've got negative pressure dust extraction in here, so that when we're doing a clean down, we can draw the dust up, we can gather the dust away and stop it going into the rest of the workshop. So it's a much nicer environment, and we've also got a lot of light in here, as you can see. We've got really good lighting, we've got all-round lighting, so we can make a better assessment of shapes. For example, on this Jensen CV8 that we're working on, we're doing a lot of changes to the body shell. The front, we've changed the front corner shape a lot, we've completely changed the rear quarter panel shapes, we've completely changed the rear valance shape. We're actually having a carbon fibre mould taken from this. This is a book rather than an actual car. But with all the shape work that we're doing on this car, it's nice to be able to have really good lighting, so that we can really see what we're doing without having to go into the paint booth every time in order to judge shape. So yeah, we've got nice light, we've got dust extraction, we've got a contained area to contain that dust, and just a general clean and fresh area where we can undertake all our body prep work. So yeah, we've been striving for this for quite a while, and now we've got it. So having referred to the fact that this is going to be a book for making a carbon fibre body for this particular car, that's not our conventional route that we would undertake on most projects. Most projects that we do are steel-bodied. So I'll kind of go into a little bit more detail on the steel body front, sort of this, ignore the fact that this one happens to be fiberglass and filler and will be carbon fibre. If this was a steel body car, our normal route would then, like the Morris Minor that we saw, the route would be that the car came into here with the zinc metal spray underneath and the epoxy primer on the top, and we would then start any basic filler work that we need. Well, prior to that we would have undertaken any lead work. I skipped over that. We would have undertaken lead fill work. We do the lead loading prior to that final blast and epoxy prime. Once we come into here, we would do any final bits of filler work. Obviously our lead should have taken care of any significant areas of fill that were required. But then we would do any further bits of filler work by hand, hand filler work to take any undulations out, any tidying up underneath the car that needs to be done, any little bits of filler required, we'd do that. And we would hand sand those. and we would then generally apply a couple of coats of a spray surfacer, a polyester spray surfacer, to most of the outside of the body shell generally, and then we would hand block all that. We would hand block all the outside of the body shell to get to make sure that we were at final shape and good condition on all of the outside surfaces, and they were all basically ready for paint. We weren't quite there yet, but they're all basically ready for paint. We don't use, or we don't tend to use, high build primers, just because of some of them are not that stable, and we have had sinkage issues in the past with various high build primers. So what we tend to do now is purely use polyester. So we use polyester spray. We will hand block all that until we're happy with that finish, and then we will re-epoxy prime again. We'll then epoxy prime over that with a high build epoxy to seal all of that in. The high build epoxy is then a waterproof primer and waterproof coating. Once that's done, we would then apply the U-Pol Raptor underbody coating, which we do, well, the epoxy primer and then U-Pol Raptor underbody coating over the zinc metal spray that's underneath the car, all the salt spray facing sections of the car underneath. We'd then apply the epoxy coat and the U-Pol Raptor over that, the truck bed liner underbody coating. Once that's done, then all the surfaces of the body shell are effectively watertight. And then we can set to on wet flatting. We actually still wet flat the final epoxy high build coat that went over the polyester. We'll wet block that, we'll get that to an 800 grit finish all over, and do a final shape assessment, make sure that we're happy that there's no waves in anything, that everything's good for the final shape. And then at that point, we'll then go and we'll do our water-based base coat and final lacquer finish over the whole car. That's a general sort of synopsis of our process route in the body prep area. There are variations on it. Not every car is the same, and there are changes along. But as a quick sort of synopsis of what would generally happen on most builds here, that's the general process route for body prep. So at that point, we would have probably yo-yoed back and forth a little bit in that route to the paint booth, obviously, to put those various coatings on. But at that point, that seems like a good time for us to wander in the direction of the paint booth. So yeah, the next bit is our new paint booth. This is new to us. It's not brand new, but it's new to us. And this is, yeah, we obviously had a paint booth before, but we've upgraded. We wanted to change over to full floor extraction, so we now have that. It makes a big improvement in the airflow. It slows the air down. So for when you're painting the outside of a car, you want the airflow to be very linear from the top to the bottom, so that all the overspray is just drawn away, taken straight downwards, and also any dust is taken straight downwards. So that's what we now have. This full floor means that when Gaz is painting, Gaz is our painter, he does all our paint work. When he's painting, the overspray isn't being drawn around the car. Our old booth was still floor extract, but had a centre pit extraction from underneath the car. So the overspray from painting the roof, say, if I was spraying the roof here, the overspray would roll around the car and be drawn underneath it. And there's a reasonable speed to that overspray being drawn around the car, and it would cause it to then possibly touch other parts and just create general problems with the paint finish. Nothing horrendous, it's perfectly workable, it can be done that way, but it's better if it's done this way. The overspray is drawn away nice and slowly, gently, and without dropping over other parts of the car. And it also means that the whole floor is extracted from a dust point of view. Again, with a centre pit extract, there are flat areas of floor at the sides that can then gather dirt, and then that dirt can be fired back up into the air by turbulence and then drop on bits of the painted finish and cause dirt issues in the final paint. So the full floor extract's a major upgrade there. That was one of the things we wanted to do. The second thing we wanted was LED lighting, which we've now got in here. This is all LED lighting, daylight bulbs, so that gives us a good light finish. We're pondering whether we need some more light low down, but I think we're okay at the moment. So we've got the LED lighting, got the full floor extract, and then the final thing that we wanted to do for our booth upgrade was to have blowers for drying water-based base coats. We now use water-based base coats on pretty much everything, not all the time, but most of the time. And one of the problems is that they're very slow and quite difficult to dry using normal booth airflow. They have a tendency to skin over but not dry all the way through. So to dry them, you need high velocity airflow, not too much temperature. So to that effect, we've now got what Junair, the original manufacturer of this booth was Junair, what Junair call quad blowers in the corners behind these lids, and they open, and there's a series of nozzles in there, and there are blowers in the roof of the booth which draw filtered air from the roof plenum and blow it out through those nozzles at quite a high velocity and create a lot of turbulence in the booth. With the booth running as well, so any dirt is still pulled downwards away from the car, but the blowers then cause turbulence, which then dries out the base coat much more quickly, but without causing it to skin over and stay wet underneath. So that was the final improvement we wanted to make, just to make it a little bit more predictable and a little bit more time efficient, and just a nicer process to drying water-based base coat out in here. So they were the major reasons for the change of booth. With the other major reason for moving the booth from its original location was that it was in the way. That was what sparked the whole process of changing over to the booth in this location. So that's our paint booth facility. We're pretty happy with it so far. We've not done a huge amount of work in it yet. It's still fairly fresh. We've done a few jobs, but not too much. So yeah, we're really happy with that. And we move on. We've got a slightly more luxurious, Gaz has now got our painter has now got a slightly more luxurious mixing room at the back here with a lot more space to work in. So we'll have a quick peep at that. So yeah, here we have our paint mixing room extracted, as you can hear by the large amount of noise. The air comes in at that end and gets drawn down and goes out there. I've still got to put a bit of pipe up there, there's a bit missing at the minute, but we've got our gun cleaning machines, one for water based, one for solvent based on the wall, and then our gun wash machine for cleaning all the other related things. And the solvent based one will be linked into our extraction. That's not actually tied in at the moment, but yeah, that's all our gun cleaning stuff. Our worktop, which as is always the case in a paint mixing room, gets covered in paint, but we can't do a lot about that. And then all of our cupboards, which have all of primers, base coats, 2K acrylics, and a whole variety of other things we use whilst painting a car here. So that's the paint mixing room, and lots of room now. It used to be very, very cramped and no space at all, and now we've got the luxury of space. So yeah, much improved. I think that pretty much sums up the strip down, blasting, fabrication, all the various parts of the metalwork process, the dry build, the re-strip down, re-blast, zinc metal spray, all the body prep operations and the paint operation, all of which happens in this space, car never leaves the site, all happens here. And that pretty much sums up all that process. And then moving on from that, we go through into what we would call the assembly shop. The car goes around the outside, we'll go through the inside, but the car will go around the outside. We don't have an internal doorway there. We don't want the dirt getting through to the assembly area, so we made the conscious decision the car travels on its trolley at that point. Every car will have a dedicated trolley made at the body prep stage. The car will travel on its little dedicated trolley around the outside and come into the assembly shop. So we'll wander through to there and show you the shiny assembly shop. So here we are in the very fresh and all nice and new and shiny Retropower assembly workshop. I think the first thing that is evident is the breadth of vehicles that we work on here. There's quite a range of ages. I mean, we have worked on newer, but from the 1980s back to the 1950s, just on this row here, and as you'll have seen in the rest of the workshop, there's quite a real broad range of vehicles that we work on. The only thing we specialise in is not specialising. It's all about the people and what they want and the passion for the cars, not about what car they are, what make they are. There's no mark snobbery, none of that here. We work on cars because we like working on them and because our customers want us to work on them. There's no brand snobbery here. As you can see, it's a very nice space to work in. We've got two baseless rotary lifts that went in this year. Nice new epoxy coated floor. just easy to keep clean, nice environment to work in, plenty of storage. And then also in the background you can see what we referred to earlier, our part storage, which is all now up there on our mezzanine floor. When I referred to the strip down of the BMW next door earlier on, we're now on Saturday. On Monday, the parts from that car being stripped down will be brought round the outside of the building and put onto the far end of that mezzanine floor. And then we have our little parts sorting area. They'll all be unpacked from their boxes, their temporary packing boxes, and we'll determine a process routing for each of those parts. So we might have a screw that we're going to reuse. And that screw that we're going to reuse will need to be cleaned, and it would then need to be possibly degreased, then cleaned, and then another process, normally a replating process. So let's say it was originally a zinc plated and yellow passivated screw. So we would want to possibly, if the car was maybe being original in the area where that screw was being fitted, we would then need to probably bead blast to clean it, and then package that part up with a number of other parts that also needed that process, and then that would go off-site actually, and unusually as a process that's not on this site, would go to the plating company that we use to be re-zinc plated and yellow chromate passivated, and then that would come back, and then that would be repackaged into a bag that we would have already predetermined it to go into on the shelf space that's set up upstairs for that car, and that part would then be in its bag ready for reassembly when that car eventually comes back round to this assembly workshop. And that's the journey of that little screw. That journey would be determined for every single piece that comes off that car. Now, quite often there's a lot of parts that are removed that go in the bin because they're being completely changed for new parts, or completely different parts from another car, or even parts we're making from scratch. But that process route is determined for every part that comes off that car, and that's all done up there on the mezzanine, and then the parts then go off in all their different directions via all their process routes, and then reconvene on the shelf ready for being assembled into the car once it makes it into here. So that's the principle of the storage up there. Some of that needs tidying because some of that is simply parts that have been moved in from our old legacy storage and our old system that need going through, and that system applying to them for the storage going forward. But that's the principle we're working with now in terms of the parts storage and the parts process routing that we do. And on that subject, on that logistics subject, there's a couple of areas I want to mention. One is I can see them in the background, so that's sort of prompting me, is fasteners as an example. We're actually working on at the moment going over to a barcode scan system for fasteners so that we automate our reordering, and that we can tie that into our supplier's barcode system so that we can then simplify our reordering process and just modernise and keep moving forward and just take process time out of things and error-proof things. So we can just use a mobile phone app, we can scan in what fastener we've just used, it'll automatically add it to a customer's bill, and then when that stock level runs low, we can automatically reorder that part. We'll just streamline things a little bit there and move things on, move things forward. And on the subject of then attributing that part to a customer invoice, customer's bill, so we use Basecamp, which is our way of tying project information together and making sure that all of our information is pooled so that everybody can see it, and we try to minimise the number of times we forget something or miss something. So that pulls out all our information and also now enables us to operate job lists for everybody, to keep people able to work on different parts of a car and able to put a job down if there's a hold up with a part, and then that job's still there and doesn't get forgotten about. So we use Basecamp to coordinate our projects and coordinate our staff. And then we also use Xero as our accounting software, and we use Xero Projects, which is a very good way of logging all of our time spent on all these vehicles. All of our staff log all of their hours spent via Xero Projects, so that at any point in time we can see what hours have been spent in total, on what those hours have been spent, and who has done what jobs at what times and how long they've taken. So we can see that in great detail on all these cars. Again, stuff that for a main dealer service operation on a new vehicle is standard, but it's a bit less common on older vehicle rebuild type work. But we're trying to, again, just move forward with these things and make sure that we're running the business as smoothly as we can in that respect. So that's another area where we're trying to move things on. Following on from that, information to customers is also very important. Something that has stuck with us really since the very first days of the business back in 2009, when Cal and I first set up the business. As one thing we discovered, speaking to a number of other restorers at the time, was that the customer seemed to be out of the loop on information a lot of the time, and that there seemed to be this sort of work either being done or not being done on their car, and the customer was somewhat in the dark about what was or wasn't being done, and then was surprised when a bill came along, and it was a general lack of communication. So what we've tried to do is make the communication a bit smoother as well, and that's gone down a number of avenues. We're actually making progress down a new avenue on that at the moment. Cal's been working on a new sort of data centre for that at the moment, which I'm not going to go into too much detail on yet, but that will be in progress soon. But at the moment, the customers get regular WhatsApp video updates, usually once a week. Cal generally does that. My brother generally does most of those. But also, most of our builds will now have a WhatsApp group associated with them, so all the relevant staff are on that group, and the customer is in that group, so that when there are questions that come up on a day-to-day basis, or design decisions that we need to make, usually often in the metalwork area, where it's kind of, right, I'm fabricating this part of a dashboard, where do we want this switch? So we can just put that information on the WhatsApp group and ask the customer directly on the WhatsApp group, where do we want this switch? And we get an answer quickly, we can crack on, get the hole put in the dash, get the fabrication done, and there's no hold up waiting for that information. So that's one area, and WhatsApp video updates as well, just to give an idea of where a project's at any point in time. The other side is also our Facebook presence. A lot of people will be aware of our main Facebook page, our sort of Retropower Facebook page, but perhaps not everybody would be aware that unless there's a request specifically not to do so, every project we're undertaking has its own Facebook page. And that's a really good way of just supplying information to the customer on a day-to-day basis, that and it's sometimes even an hour-by-hour basis, that if the photos of work every day will be popping up on that Facebook page, and the customer will be getting Facebook updates on their project, so they'll be able to see almost in real time what's actually happening on their car, because the photographs are being constantly done. And Jamie, who does all of our social media work and most of our photography work, and the weekly uncut videos that you see are all done by Jamie. He's constantly photograph updating all of the projects, so you'll be able to see almost in real time what's happening. So it's a really good information flow that we're quite proud of as a business. So that's a little bit of background on information and logistics. So yeah, welcome to the assembly shop. I shall wander along here a little bit and walk past. We've got the Project Vader Chevette at the newest end of the spectrum in here. That's going to be a pretty fearsome machine when it's finished. It's getting quite close to being finished now. I think we're into test driving that within the next couple of weeks. There are various bits to finish off, but it's getting very close to that sort of stage now. That's 290 something, I can't remember exactly, 290 plus horsepower Vauxhall 2.3 16 valve XE engine in that, and a 6-speed sequential gearbox. It's quite an exciting machine that will be to get testing. 1966 Ford Mustang there undergoing, that's kind of midway through its assembly stages. It was a straight 6 car, it's now a V8 car. There's a lot. It was an absolute basket case, that car. Very, very, very rotten and accident damaged, and pretty much in as poor a condition as you could possibly get one of these. If you look at the project pages for that car, you'll be able to see that there was almost no original metal in that car. So that just goes to show how far you can go. That was built almost entirely from replacement panels. That was probably an extreme of metal repair that we've done here. And then we carry on the The E-type Jag is actually not anywhere near being finished, which is hence the condition it's in. That's actually literally just come in. That's in for, that wouldn't normally be in this side. That's just temporarily in here, awaiting the start of process, and it's been put in here for inspection at the moment. That's a project not yet commenced. That's just in here for checking over. Underneath it, you can see our brand new inspection pit. A few people question inspection pits. There are hazards associated with them. There are pros and cons to them, but the main thing for us with the inspection pit is the ability to, on a car that's being test driven, that's just finished assembly work, we can drive out and we can drive back very quickly, get the car over the pit, double check something underneath it, then get it straight back out the door, test drive it again. And when we're doing testing, the first sort of few days of test driving can inevitably mean quite a lot of underside checks being done and rechecks and post shakedown checks. And that's where the pit's so useful. It's very easy to just swing a car over, do a quick tracking adjustment or a quick tightness check on something or a quick shake check on something, and then we can get back out and test the car again. So that's why we've got the pit. That was a conscious decision to have that and not a lift there. And then the final bay, where the Mark II Jaguar, the Utah Mark II Jaguar lives, is just a flat floor bay where, again, we can do the work where a lift gets in the way, a pit gets in the way. Sometimes you just need a flat floor to work on, well, almost flat floor to work on, to do various jobs. In the case of this, the interior assembly work, it's ideal just to have a flat area, all the doors open, we can crack on and get the interior together. This car's very, very near completion of assembly now, so this won't be too far away from its test drive time, which as usual is a real pain in a UK winter, but we have to put up with it and cope with it. And then around us you can see tool storage galore. We've got all these lovely British made bot cabinets surrounding the place where we have all the sort of general use tools now. Everybody, all the guys have got their own toolboxes, but then we've also got all the sort of the general tools that we all use, the pullers and the taps and dies and the air conditioning refill kit and all of the generic things that you need when building a car all now have places to live. It's all very neat. We've got the air lines, we've got the oil line feeding the heating, we've got all our lights here. It's just a nice, bright, airy place to work. That we're really quite proud of now, and we've worked for a long time to get to this stage. And we now have a workshop that's really a really lovely place to work and a lovely place to build our customers' cars. So yeah, I think that wraps that up. So moving on, we'll wander over here, and we have our Kaiser 2 Mercedes project that has been out on test drive quite a bit recently. We've been doing a bit of work on the rear suspension development on this because we weren't quite happy with the refinement. That's why that's here. And it's in this space here now is quite a nice easy area for cars to go out, be tested, come back in. We can do rapid changes to things. Again, we can get over the pit if we need to. We can swing in and out when we're road testing. So it's an often glossed over part or a missed part when it comes to building vehicles, is that it's accepted that car manufacturers put a lot of testing into a vehicle. Well, we often, because we've built a car from more or less from scratch, not necessarily along the prescribed route that a manufacturer would have used, is that we need to do quite a lot of testing. Obviously we never get the chance to do the level of testing that car manufacturers do, but we do need to do quite a lot of road testing. Several hundred miles worth at least to test most of the parts that we put in a car. We need to make sure that all the systems that we've modified, built from scratch, engineered, re-engineered, that they all work and operate correctly. So that's what this has been doing for quite a while now, on and off. There's various bits of work we've had to go through quite carefully on the rear suspension. There was a bit of a refinement issue that we had that we've been going through for a while, and that we've now got to the stage where we're happy with it. The car is on air ride, I hasten to add, that's why it sits at that height at the moment. That's on air ride all round, and that's, we've been along a bit of a development path with the rear air ride units on that, but we're now at a stage where we're happy with it. So that's good. But that's a good example of a vehicle that's at the point of handover to the customer, but testing is ongoing, and where we can't, there's no shortcut to doing that testing. You simply have to clock up miles and see whether you're happy with refinement of things, whether there are any problems with anything. It's just a thing that has to happen. And then in the background of the shop, you'll see a lot of cars with covers on. Those are there for a whole variety of reasons. There's no single reason why those cars are there. There are cars where we're waiting to do work on them. We're waiting for a space to become available to do some work on them. And there's 2 examples there. There are cars where they're programmed in for work, but it hasn't been started yet, there's another couple of examples over there. There are cars that are on pause at the customer's request, where we've done a lot of work in the past on those cars, and therefore it isn't really fair of us to say, right, that's got to go away to paid storage now. We'll just accept the fact that we're going to store that car for the customer for a while before we can re-pick up the work on that. That all depends on, there's a reasonableness to the relationship between us and our customer, where we decide, yeah, we'll store that car for you for a while until we can carry on working on it. And then that is reciprocated in that there are times when we can't work on the car at a point where a customer would quite like us to work on the car, and we're storing it then until we can work on it. So it would be nice not to have to store vehicles, but inevitably in any of the business of this type, unless you're very mercenary and your customers are equally mercenary, you will always end up storing vehicles at some point. Plus, there's also some vehicles of our own. My Range Rover standing, towering over things at the back there is my own Range Rover Classic that's kind of hiding at the back there, waiting for me to get 5 minutes to work on it, which I never seem to do. So that's towering over things at the back there. But yeah, that's the main reason why there are a number of vehicles there is storing, awaiting work by us, storing, awaiting customers go ahead to continue work, and that basically captures the bulk of those, plus a couple of our own vehicles as well. So that's why there are all the shadowy figures lurking in the workshop. And I think at that point, that pretty much covers everything that's around us here. So we'll wander on back out, and there's a couple more things to glance at on the way out. So I shall march on. So last room that we haven't seen yet is, other than toilets in the kitchen, is our engine build room, which is a bit messy at the moment because there are a lot of projects in various states of flux. I wouldn't normally have dirty engines in here, but this has literally just been removed from the BMW next door, so this is awaiting strip down. But generally this is a clean engine build room. And transmission, we'll do differential builds in here. We do a few gearbox builds, not too many, but we do a few gearbox builds in here as well. But as we do undertake a number of engine builds in-house. We don't do the engine machining work here. We don't have the facilities to do block machining, cylinder head machining, that sort of work. We've got a subcontractor that's very local that does that. But we do a lot of final engine build work here. With the work we've got around us at the moment, we've used a lot on recent builds. We've actually used a lot of crate engines, so there hasn't been much activity in here recently on our online videos. But there will be soon. We've got the engine to build for the Land Cruiser next door, and we do undertake an amount of engine building. So this is the room where that takes place, where it's relatively clean. We can do measuring with reasonable precision. The temperature is fairly consistent. It's just a nice place to not have to worry about grit and dirt, because it's part of the office building, the office section. We don't get too much dirt ingress in here, so it's just a nice place to put engines together. So I think that rounds off our little tour. I hope you've enjoyed that little project's eye view of the process route through the business. The business is it's a business that's grown markedly over the years, and our ethos has always been to try and do the maximum amount of work in-house wherever we possibly can. And that still stands today, as you'll have seen from looking around that little walkthrough. We really do try and keep everything we can do in-house, so that we're in control of the quality and we're in control of how the jobs are done, right through from the design stages at the beginning, through all the intermediate dirty processes, through the finish, through the final builds, through the test driving, all the way through to hand over to the customer. We really do like to keep everything here in one place, under one roof, where we're in control of it. So I hope you got a good flavour of that from that little project walkthrough, and I better get back on with some work.